Good morning. Okay, good morning, everybody. It's
Morning.
March 15, 2026, and we got St. Patrick's Day coming up. And winter, we had a brief respite from winter, and then it came back again. So, Ian, are you going to celebrate St. Patty's Day?
Well, yes and no. Whether I'm going to celebrate it particularly is an interesting thing because do you remember James Aratoon and his work
Yes.
on O'Rahilly? You'll be interested in this, Harry. So he's been threatening to come over to Ireland, and maybe I would help him to go down to University College Cork, where O'Rahilly was professor and president later. So he's coming over, and we're going to be in Cork on St. Patrick's Day. So I met him last night. He's in Dublin at the moment, and we had dinner together. So we've planned the week. He's gone down to Cork today. I'm going tomorrow, and we're going to spend all of Monday, which is the day before St. Patrick's Day, just going through the archives. And then we're going to do. We might look at the parade in Cork, or we might do a bit of touring there. And then I'm coming back to Dublin, and then he's coming back. He's going to stay with me 2 nights. He's here for the week. So
Well,
I don't know
that's
if I'm.
very interesting. I'm glad that that's coming to fruition because Raleighy's book is very interesting and his work is very interesting, and hopefully we'll learn more about his work. Okay, thank you for that. Let's see, we have Rick Amelsfort to talk to us today about Halton Arp, and good morning to you.
Good morning. How's everybody?
Warm, thankfully.
I thought you said winter had come back.
Yeah, we had a storm on Thursday and it snowed, and it was quite a big shock. The temperature dropped from mid 60s to mid 30s in a matter of a couple of hours, and it had been in the mid 80s. The temps here had been in the mid 80s. It was summer-like. It was really warm and hot. And then we had snow on Thursday.
Goodness me.
Okay.
Sounds like Canada.
It's a big shock for us here in Newport News. I mean, we're in the coastal Virginia.
Yeah, yeah. I know it's usually warmer down there.
All right, we're ready to go.
Well, good morning, everybody. This is my presentation on Halton Chip Arp. Chip is his nickname. And it's about his findings on intrinsic redshift, which he calls intrinsic to quasars. Here's an overview. Halton Arp, 1927 to 2013, he began his career at the very heart of the scientific establishment, with Arp's PhD advisor of record being Walter Bade, and later Edwin Hubble, both titans of the 20th century astronomy. Arp arrived at the Mount Wilson and Palomar observatories as a graduate student from Caltech. During the final years of Edwin Hubble's life, assistant to Hubble, Arp worked directly under Hubble, helping to refine the distance scale of the universe. So he was working on figuring out redshift and expansion and all of that. Arp conducted a massive study of novae in the Andromeda galaxy M31, which provided a crucial standard candle for measuring galactic distances. And he had access to the 200-inch Hale telescope, then the most powerful instrument in the world. Following his PhD, Arp became a staff member at the Carnegie Institute of Washington. This was the most prolific and universally respected period. Discovery of interacting galaxies, Arp was among the first to prove that many peculiar shapes were caused by galaxies physically colliding or passing near one another. During this time, he was a mainstream star, widely cited for his impeccable observational skills and high-quality photographic plates. The turning point in Arp's career came when he began noticing, excuse me, what he called discrepant redshifts. Arp found several instances where a high redshift quasar, which should be billions of light years away, appeared to be physically connected by a bridge of gas or dust plasma to a low redshift galaxy, which should be much closer. He proposed that redshift was not always caused by expansion of the universe, the Big Bang theory. Instead, he argued that quasars were offspring ejected from the nuclei of active galaxies, Seyfert galaxies, and that their high redshift was an intrinsic property of their young age. This challenged the Hubble law. If Arp is right, the Big Bang theory is fundamentally flawed. The astronomical community largely dismissed his findings as chance alignments, optical illusions. His loss of telescope time in a move that remains controversial today. The Palomar Allocation Committee denied Arp further time on the 200-inch telescope, arguing that his research was unproductive. And I'm going to butcher this name, Subramanian Chandrasekhar, editor of the Astrophysical Journal at the time, and a really big person in the field, wrote on his paper, "This exceeds my imagination." Well, if you don't have an imagination, what are you doing in cosmology? Feeling censored in the US, Arp moved to Munich, Germany to work on the Max Planck Institute for Astrophysics, where he later refined the intrinsic redshift model. He spent his remaining decades using X-ray data from the ROST satellite to try and prove that quasars were clustered around nearby galaxies. And this is his experience, where he worked and what he did. So in the 50s, he worked at Caltech Mount Wilson, mentored by Hubble and working on Seyfert variables and M31. In 66, he went to Palomar, published his Atlas of Peculiar Galaxies. In the 1970s, he was at Palomar Observatory, identifying bridges between high and low redshift objects. There are many. In 1983, 2000 to 2013, he was at Max Planck researching intrinsic non-cosmological redshifts in exile. He inherited Hubble's skeptical approach to grand cosmological theories, and I'll touch on Hubble at the end, and his intense focus on observational evidence over mathematical models. It is deeply ironic that Arp, the man who would later try to dismantle the Hubble law, the idea that redshift equals distance, was trained by Hubble himself. Don't you think? I do. He wrote several books for a general audience detailing his struggle against the Big Bang establishment. Forced to resign from the Carnegie Institute of Washington observatories after the Caltech head threatened him, saying, "Unless you change your line of research, we will take your telescope time away." And this is his papers. They can be found at www.haltonarp.com. If anybody wants to go there and read his papers, feel free. First one is intrinsic redshifts in quasars and galaxies. Next one is high redshift galaxies to the blue Pacific. I don't know what that means, but quasars and galaxies, gamma ray and bursters, and fingers of God in an expanding universe. Those are his papers. Some of them. Here's another little bit. Is physics changing? Origins of quasars and galaxy clusters. The observational impetus for Lesage gravity. A symposium on active galactic nuclei. And a couple of more papers, research with Fred. I don't know what that, who that is, but, and then rebuttals from
audio input.
And these are Halton Arp's books. The Redshift Controversy in 73. Quasar redshifts and controversies in 87. Seeing redshifts, cosmology and academic science.
Seeing Red.
Seeing Red.
That's available online. That's a very good book.
Yep, you can download that. Most of these books you can probably find them in PDF form. Catalog of discordant redshift associations. Catalog of southern peculiar galaxies and associations with Barry F. Medor. And here's Halton Arp himself. And one of his books is Catalogs of Discordant Redshift Associations. Now here's an interesting object. NGC 7603 with a absolutely undeniable physical bridge between this object, which is a quasar, which is, they quantify it as a quasar, and these two little dots here and here within the stream of plasma itself, and they're quasars as well, and they have redshifts that are high when they're first born, and they go lower as they get further away from the galaxy as they get older, and they get even older or lower as they get even further away. At some point, this will grow and get larger and older, and it will match the redshift or get even closer to the redshift of NGC 7603. And here's NGC 4319 with another obvious bridge to Mercurian 205. It's undeniable. You can see it in the radar and in the radio images. You can even see it in the optical. It's undeniable, in my view. And I'm guessing this is his later work, where he's identifying quasars along the axes of galaxies, active nuclei of galaxies, in other words, Seyfert galaxies. And he's plotting the redshifts, and you can see as they're high as they're being newly ejected, and as they get further away from the galaxy and older and drawing, getting bigger and growing, their redshift lowers and drops. And there's a whole bunch of these. There's a plot. there's a whole bunch of these, and I'll show you that in a few minutes. The conclusion is that many colleagues defended him to no avail, and many of them agreed with his conclusions that some redshifts are inherent, not due to distance and velocity. Here are a few big names and highly respected cosmologists that liked his work: Margaret Burbidge, her husband Geoffrey Burbidge, Sir Fred Hoyle, Jack Sulenek, who saw the original non-doctored images of which I can't remember which galaxy. I think it was the one that was connected to Markarian 205 NGC 4319, and Martin Lopez Cordania, who with his partner confirmed Arp's work on some galaxies. John Dobson. It's not a question for debate that in fact some quasars are physically connected to lower redshifted objects, galaxies. The mainstream will point to those doctored images and say, see, he was wrong, and we are right. Like they always do. The centers of galaxies are where creation is taking place, not some Big Bang billions of years ago. Geoffrey Burbidge quote. What's really happening in these systems is that the centers of galaxies are where creation is taking place rather than just in a Big Bang. And so you're looking at all the mini bangs where matter and energy are literally being created. The Armenian astronomer Victor Bartsinium postulated that the galactic centers was where creation was taking place. And that, my friends, is the end of the presentation part. Let me drop this down. And here's a bunch of Arp's own quotes. If
Well,
you
they're
want,
real tiny.
yep. I won't bother with them, but they can be found. There's a bunch of PDFs of all of his work. There's tons and tons of information on Halton Arp, and if you went and looked at it, I think you would change your views of redshift entirely.
I'm not really
Redshift has,
sure there's anybody here that really maintains the mainstream position, is there? At least not in our group.
right. Well, Halton Arp is the proof that everybody's been looking for a non-Big Bang cosmological redshift.
He
Research him
argued
some
that,
more.
yes.
Yeah.
He's not the only one, of course.
No, there's been a few.
He's probably the most prominent in terms of them essentially forcing him out of the mainstream is kind of a sort of a primary example of their resistance to doing actual science.
Right. Well, I mean, Halton
Okay,
Arp
I'm sorry I
is the
interrupted your
case.
presentation.
Oh, that's all right. We've got lots of time.
Do you have any more here to talk about? Do you have some pictures or the
Yep.
pictures are pretty impressive.
Well, they're all on his papers. All of those pictures are all on his papers. If you go to his website, haltonarp.com, you can find them there. It's all there.
Rick,
People,
can I ask a question here?
sure, James, go ahead.
What I'm understanding is that you're saying, based on Arp's work, that physical objects like these galaxies or quasars or whatever they um, are located very close to each other, but with respect to the gigantic distances in the universe, located close to each other and yet have different redshifts. Is that what ARP is actually saying here?
Yes.
I just wanted
He's saying that these quasars are actually associated with the galaxy. They exist on the axes of the galaxies that they were birthed out of. And the mainstream see these quasars as being billions and billions and billions of light years in the background of these objects, of these galaxies that
so
Harp
they're
says.
saying that they're not really spatially juxtaposed.
Yeah, they're many billions of light years away from this galaxy that you're looking at. That's what they're saying. And Halton Arp is saying no, based on their redshift and the quantization of that redshift, where it looks like these objects redshifts are changing, are lowering as they're getting older and further away from the galaxy. And there's many instances of that phenomena uh, on many galaxies, too many to be coincidence. One or two, you could see that being a coincidence, but there's hundreds of these galaxies that he's mapped that have that same system where redshifts are high, close to the galaxy that birthed it, and as they go away further and further, they're lower and lower redshifts. Too many of them to be coincidence. But
Okay, now
as I was going to say, Arp is called the Galileo of Palomar. He is the Galileo of modern astronomy, and for good reason. Chandrasekhar said he had no imagination to think that this was happening. Well, if you can't have an imagination and you're in a position like that, and you're not prepared to question the current model, why are you even there? Is my question. Go and do something else if you're not open-minded. Anyhow, that's me ranting.
Well, there's nothing that says science is about being open-minded. Science
Yeah,
is about conforming to the established knowledge base.
true enough. True enough. I'm going to go to my phone here and bring up some information about what Edwin Hubble thought about the Big Bang. In his later years, Edwin Hubble remains highly skeptical that redshift of galaxies was caused by true expansion of the universe. While he provided the observational evidence that led to Hubble's law, the father of galaxies that have greater redshifts, that further galaxies have greater redshifts, he consistently referred to this phenomena as apparent velocity rather than actual physical recession. So those are the words of Edwin Hubble himself. He did not believe that redshift was caused by distance and velocity away from us. He probably was looking at Arp's work and agreeing with him. But anyways, that's just speculation on my part. All right, well, I'm gonna bring up a couple of videos, 3 videos, and enjoy.
Okay, we only have like 15 minutes.
I only have 15 minutes. This one's only 7 minutes long, so I'll play this
All
one
right.
and take a couple of questions, and then we'll play the other two at
Okay.
the beginning of the next one.
On December 28th, 2013, the acclaimed astronomer Halton
The
Arp
volume is
Oh, the
rather
audio.
low.
86 in his home in Munich, Germany.
Is that better?
Arp posed a challenge to the very
Yes.
foundations of modern cosmology.
Yeah,
A
that's
challenge
good.
that only grows more relevant with new, astonishing discoveries. We present Walt Thornhill as we honor Arp's remarkable contributions to science and astronomy.
I was first introduced to Halton Arp's work by Mel and Amy Aitchison after one of our very first meetings in Portland, Oregon. They could see the relevance of Arp's discoveries to the electric universe that I was then presenting. That was in the mid-90s. In September 2000, I had my first meeting with Halton Arp in Portland, once again at one of the Electric Universe meetings. And it was quite a historic meeting because of the other people who were there, in particular Tony Peratt, who is known for his groundbreaking work in plasma cosmology. And the input from both of these people to the electric universe has been considerable. It was only a month later in October that I actually shared the stage in London with Halton Arp. Unfortunately, he was busy at the time, involved with a filmmaker making the documentary The Cosmology Quest, which is now available on DVD. Halton,
I'll be showing a piece of that Cosmology Quest video, by the way.
known as Chip Arp, was a professional astronomer who, earlier in his career, conducted Edwin Hubble's nova search in M31. He earned the Helen B. Warner Prize, the Newcomb Cleveland Award, and the Alexander von Humboldt Senior Scientist Award. For 28 years, he was staff astronomer at the Mount Palomar and Mount Wilson observatories. While there, he produced his well-known catalogue of peculiar galaxies that are disturbed or irregular in appearance. Arp discovered that many pairs of quasars with extremely high redshift values are physically connected to galaxies that have low redshift and are known to be relatively close by. Yet according to the Big Bang expanding universe, the high redshift quasars must be located far behind the nearby galaxy. Because of Arp's observations, the assumption that high redshift objects have to be very far away, on which the Big Bang theory and all of accepted cosmology is based, has to be fundamentally re-examined.
While mainstream cosmology has come to embrace the story of the Big Bang and the expanding universe, cosmologist Carl Sagan noted the challenge that Halton Arp's discoveries pose to the standard theory. In his 1980 bestseller Cosmos, Sagan wrote, "There is nevertheless a nagging suspicion among some astronomers that all may not be right with a deduction from the redshift of galaxies via the Doppler effect that the universe is expanding. The astronomer Halton Arp has found enigmatic and disturbing cases where a galaxy and a quasar, or a pair of galaxies that are in apparent physical association, have very different redshifts. However, some believe that institutional science's response to Arp's challenge is a disturbing example of political suppression."
Arp's life story exemplifies everything that's wrong with modern showbiz science. His paper, Companion Galaxies on the Ends of Spiral Arms, which offered a fundamental challenge to Big Bang cosmology, had Subramanian Chandrasekhar's scrawl across the top corner, "This exceeds my imagination." That may have been so, given Chandrasekhar and those like him had a great deal to lose, but it was not a scientific reason for rejection of Arp's observations. However, Arp's telescope time was curtailed and he was forced to continue his research in Germany. Halton Arp has been dubbed a modern Galileo because other scientists refuse to see what is obvious even to amateur astronomers, that low redshift galaxies are often found connected to high redshift companions. Clearly, most of the redshift is intrinsic to the companions. At a single stroke, Arp removed the foundation for Big Bang cosmology. He had in fact proven Edwin Hubble, his mentor, correct, for Hubble had written in the Royal Astronomical Society monthly notices in 1937, and I quote, "If the redshifts are a Doppler shift, the observations as they stand lead to the anomaly of a closed universe, curiously small and dense, and it may be added, suspiciously young. On the other hand, if redshifts are not Doppler effects, these anomalies disappear and the region observed appears as a small, homogeneous, but insignificant portion of a universe extended indefinitely both in space and time. End of quote. The irony is that the constant defining the hypothetical rate of expansion of the universe bears Hubble's name. The winners rewrite history. Arp proved Hubble right. We live in a universe extended indefinitely both in space and time. Halton Arp believed in the scientific approach more strongly, it seems, than do mainstream scientists. Arp notes that his opponents invariably stated that, and I quote, "The observations cannot be accepted because there's no theory to explain them." End of quote. Of course, the companion statement was always, and I quote again, "There is no need to modify conventional theories because there are no valid observations which contradict them." Clearly, these two statements have always provided the perfect double bind against progress in the subject. Arp has had dramatic confirmation, which involved also Sir Fred Hoyle, Geoffrey and Margaret Burbage, and J. Nalika. And he says, with one object, NGC 3516, we had confirmed 1, the alignment of quasars along the minor axis, that is the spin axis of the parent galaxy. 2, the decay of the redshift and increase of luminosity as the quasars travelled outward. 3, their evolution into companion galaxies. And 4, and very important, the quantization of the evolving redshift steps.
Right there, they confirmed Arp's work that quasars were being birthed out of active galaxy nuclei, Seyfert galaxies, and that as they went further and further out, their redshift lowered and lowered, and then they turned into galaxies themselves.
Arp writes, since science is supposed to be characterized by successful prediction, it is significant to note that this most important single observation of quasars being ejected from an active low redshift galaxy was rejected without ever being sent to a referee by that leading journal of trustworthy and important results, Nature magazine. Arp also writes, the most influential people in the field, in their jovial camaraderie, would simply ridicule anyone who had reported discordant results. How can one fight rumour? I think the
Gatekeepers.
only answer is that one must fundamentally change the structure of academic science. Communication must be directly to fellow researchers and the public, with no chance of censorship. The cancelling of Arp's telescope time and the suppression of all discovery mode programs is a testimony to the extreme fear that the opposing side has of this kind of research, that they would ruthlessly seek out and subdue this small effort. On the other hand, it raises the question of whether the enormous financial, engineering and administrative effort put into astronomical research today is being wasted at the point of application by scientists who believe they already know all of the important answers.
Yeah.
That it?
Well, I got 2 more videos, but time is running low,
Okay,
so I'll take some questions.
We've already got the warning. So, okay, any comments or questions here before we close out this segment? Jim, do you have any?
Ido here, just a short comment. This work that's presented here by Halton Arp is one of the key pieces of information for me that makes it tangible to really pay attention to what's being said here, in contrast to the Big Bang, of course. I find it very convincing and worthy of a lot more research, I would argue. That's all.
Agreed.
Well, it kind of turns everything they've been working on for years and years on its head, which is why they don't want to acknowledge it. Because it really pretty much invalidates the whole what's in the textbooks and their whole paradigm. You know, the paradigm of there was a Big Bang that created a bunch of hydrogen. The hydrogen condensed to form stars. The stars, the protostars or the early stars, then had nuclear reactions in them that created lithium and carbon and elements on up the scale to iron. And then you had supernova explosions, which then ejected the heavier elements out into space, and then they condense to form stars, and you repeat the process. And this is their paradigm. And the whole idea of what our ARP is presenting is essentially contrary to the whole everything that they've developed as a theory for the origin of the universe and the creation of the elements and stars and planets.
Well, you can equate it to biological reproduction, where this galaxy is giving birth to these quasars, and these quasars are growing up over time into galaxies themselves, and then perhaps turning into Seyferts and giving birth to other quasars. It may have all
That's a
started.
non-scientific concept as far as the mainstream is concerned, although their ideas are pretty non-scientific too.
Right. Well, that may be exactly what's happening, though. That may exactly be what's going on in this universe, that it may have started with one galaxy
What
and then birthing and birthing and birthing and making new galaxies and expanding out that way. The expansion may be happening, but not in the way that a Big Bang expansion happened,
in support of that, Rick, nature, and very scientific, by the way, is filled with examples that you need something in order to create something. The cell membrane is an example. You need a cell with a cell membrane in order to create a cell with a cell membrane. You can't create the cell membrane from the get-go. Same is true with the chicken and the egg, right? Which came first? The nucleus or the atoms or the elements may be a similar thing. In order to create, between brackets, the neutrons, you already need existing neutrons and an existing nucleus to create more nuclei. So the concept here of, on a larger scale, of galaxies giving, between brackets, birth to another one, I find actually, still scientific and quite an interesting concept.
Right. I agree. It's more natural than we think space is. Electricity and plasma behave like biological systems. That's why plasma was coined plasma by Irving Langmuir, because it acted like blood plasma. It acted like a biological system. It did things that are done by biology. So he coined the phrase plasma.
My point that I was making is that this mainstream community resists the idea of an analogy between physics and biology because they're on top and biologists are down below the physicists in the hierarchy of science. And
Same with chemists.
I don't think they want to admit that biology has anything to contribute to physics. I think that's really what the issue is.
That's part of the problem, is they separate themselves into cells. This science and this science and that science and the other science, and they don't even talk to each other.
Right.
And that's the
okay,
problem.
We're coming up to the end here. That's Charles Lucas's silo theory. I don't know if you're familiar with Charles Lucas.
No,
unfortunately, we haven't heard from him in several years, and we don't really know much whether about his health. Apparently, is in trouble, and Dennis Allen apparently. I don't know that anybody's been in contact with him. But anyway, he used to talk a lot about that when he was active in the CMPS.
I'm not familiar with him. Sorry, no.
Okay, well, another person who used to engage in our Saturday morning conversations that has faded into memory, and we're not really sure whether.
Who used to appear on the Saturday shows and is no longer around.
Charles Lucas.
Yeah, but you said there was another person as well as that. No.
Dennis Allen, I mentioned.
Yeah, no, he's still around.
Um, yeah, Charles Lucas used to the point was making there is Charles Lucas really emphasized that point, which he called the different silos of science. And he used to come on Saturday mornings and talk about that almost, I mean, very consistently. That was one of his major points that he made. And I'm surprised that you don't remember Charles Lucas. Um, does anybody here remember Charles Lucas?
Of course, I remember him. Yes, I've been in contact with him as well. He's written these books, The Universe of.
Right. And I've been sort of hammering on people that well, I'm sort of Dennis Allen has reported that he was in an automobile accident, but that was several years ago, and we haven't heard from him since then. And so I don't know what happened to him. There's other people who are like that were active in the CNPS and the dissident community, and they just kind of faded away and disappeared. And we don't really know what happened to them. It's kind of strange. Um, um,
Such
so I guess,
as, have you got any other names, Harry?
excuse me.
You
Well,
said that's what I'm
I was
wondering.
look I was looking at a book the other day by Al McDonald. Um,
Oh,
uh,
yes.
do you- and I went on the internet. He wrote this book, Uncommon Knowledge, which I have a copy of. And I was looking through my library, through the bookshelf, and I came across this book, and I thought, oh, I haven't seen this book in a while or thought much about it. And and I was thinking about doing a presentation about his book, and and then I went on the internet and I tried to figure out what happened to him. And I did a search. Is he alive? Is he dead? No, I couldn't really find any obituaries or anything. He just kind of disappeared, you know.
I think he was more involved in Glenn Baxter's group. I don't think he ever got really involved with the NPA, as far as I
That
recall.
could be. I know that yeah, I know that that's how I got associated with him was through Baxter, Glenn Baxter, who unfortunately died of cancer, and that's kind of a unfortunate. Um, and we're losing these people, and we don't know what happens to them. So I'm sorry to interrupt your presentation.
Oh, no worries, no worries. It's all
Uh,
good.
I did want to point out a little bit before you proceed further that I've read a number of these papers, and one of the things that he did was he spent a lot of time doing the mathematics of showing that these associations that you're referring to were not likely to happen by chance. He did these statistical studies of given a distribution of a random distribution of quasars across the
Yep.
sky, that it was not probable, that it was highly improbable that these quasars could be associated with galaxies
As I
by
mentioned earlier,
accident. By accident. In other words, he showed
by
mathematically
chance.
that the chance probability of these associations occurring by accident or random chance was extremely low. And of course, that was not accepted by the mainstream. They rejected that. You know, it's kind of
Almost,
interesting. They like to use probability when it supports their argument. When it doesn't, then they don't accept it.
almost impossible alignments.
Correct.
I mean, there are too many of these galaxies, these Seyfert galaxies with quasars being ejected out of them to be coincidental. To, like I said, it's just almost an impossibility that this structure around a Seyfert galaxy is chance by, anyways, as you can see, some of these images, they're offset of the exact center of the axis of the galaxies that they were ejected out of. That leads me to believe that it's shaped like a cone. The Birkeland current is cone shape as it pinches into the galaxy, and when a quasar is ejected, it follows along one of those edges of the cone.
So you're saying it's nutating.
It's what?
There's a term called nutation where the axis of a top goes around in a circle, creating, well, it's called nutation, I think, if
Mutation
I'm
is the
correct.
technical term.
Okay. I didn't know that term, so. But that's what we see in the Earth. We see that in the Earth with its magnetic field. We see that now. I pointed it out in my last video that last couple of probes that they sent to the north and southern poles of the sun are seeing these expanding spirals in the northern and southern poles of the sun. And this is what we're seeing as well with these quasars. We're seeing that exact same phenomena, but on a larger scale, a Birkeland current that is feeding this galaxy in the center here. Okay, moving
May I
on to
ask a question? Obviously, these observations are something that mainline science cannot deal with. It's outside their ken. But am I not correct in assuming that ARP didn't counter the contention that there was a redshift, say in a galaxy without these quasars attached, or indeed in the galaxy itself, and that redshift did in some way increase with increasing distance away. And if that is so, and he didn't contest that, um, he presumably did contest the Doppler explanation of that. But was it within his ken to conceive of a sort of a tired light, an energy dissipation being the primary cause of that redshift?
I haven't seen anywhere in his work that I've been exposed to where he talks about a tired light, but it has to be that it's a combination of all three. It's a combination of Doppler, it's a combination of tired light, and it's a combination of intrinsic redshift. Where if you did enough research, I think you would find that some of these lower redshifted galaxies are connected to these blue shifted galaxies along their axes. And if I may for a second go back to one of these images, this one here, you can see it ejects a quasar. It turns, redshift lowers and lowers as it goes out, and then it tends to come back down and park itself around the galaxy somewhere, or spread out laterally away from its newly birthed quasar as it grows older down here and turns into a galaxy, and it's spitting out galaxies in another direction because it's oriented in another direction. This is the birth cycle of galaxies. We don't think they have a death cycle, though. We think that they go on as long as they're being powered by the Birkeland current that they sit on, which is obviously in this direction. And then there's a change, which electric discharge does 90-degree angles and 45-degree angles beautifully. Naturally, it just shifts off direction and goes 90 degrees, 45 degrees as a matter of its nature. Excuse me. Okay, here we go with the second video. It's only 5 minutes long.
In part 2 of this presentation, we continue our discussion of late pioneer Halton Arp's contributions to science and astronomy. Proponents of plasma cosmology in the electric universe have paid special attention to Arp's theoretical research, including his thesis of intrinsic redshift. Arp's discoveries allow for a new cosmology free from the assumptions of the Big Bang and its bizarre mathematical speculations.
Arp's contribution to the electric universe is of fundamental importance because both are based on observation and experiment instead of mathematical speculation. Arp's discovery of the quantized redshift of quasars revealed the nonsense of particle physicists who believe that quantum effects only apply to the subatomic realm. Quasars are ejected from the nucleus of an active galaxy at a good fraction of the speed of light, which implies the matter in the quasar has extremely small initial mass. The quasars then slow down to become a companion galaxy, which implies their mass increases in quantum jumps over time. Arp was very interested in the implications of his discoveries. He related the frequency of the redshifted light from quasars to the youthfulness of newly created matter. He wrote in Seeing Red, "The younger the electron making the orbital jump, the less massive it will be, and the weaker, that is more redshifted, will be the emitted photon. Moreover, as the particles age, they become more massive. Therefore, the ensemble becomes more luminous. As its luminosity grows, its redshift drops, evolving into what we consider normal galaxies like our own. Also, as the assemblage ages, its growing mass slows its initial high ejection velocity in order to conserve momentum. The galaxies finish with very slow relative velocities, as observed. This is the kind of theory we are looking for. Simple, capable of being visualized, one that can connect together the puzzling observational facts that presently confound understanding." That's the end of that quote. However, this is a radical assault on the beliefs of physicists because it puts a searchlight on the fact that they have no real explanation why matter has mass. It also shows that some of the cherished physical constants are quantized variables. Arp wrote, and I quote, "For the first time, we have hard observational evidence for the evolution of different forms of organized extragalactic objects, the birth and maturing of younger objects into older objects." End of quote. This is a completely different view of the universe from the incoherent Big Bang. It accords perfectly with the work of plasma cosmologists who can explain the beautiful spiral form of galaxies in electrical terms. Arp was aware of plasma cosmology and the electric universe, and had come independently to much the same conclusions concerning the Big Bang and the need for a new cosmology. Plasma cosmologists have an electrical galaxy model where current flows along the spiral arms to the center of the galaxy, where it is stored and intermittently released in jets along the spin axis. The centers of galaxies are simply explained not as impossible black holes, but as the most concentrated form of stored electromagnetic energy.
That, my friends, is Hannes Alfvén's work right there.
Known in the laboratory as a plasma focus, and used sometimes as a particle gun. So quasars are shot from the heart of their parent galaxy by prodigious electromagnetic forces. Of course, mass and energy are related by the well-known equation E equals mc squared. So the mass of the galactic plasmoid at the center of the galaxy, which may be less than the size of our tiny solar system and composed of relativistic charged particles, can produce the observed gravitational effects of billions of stars. There are no black holes. The electromagnetic jet that connects the parent galaxy to its baby quasar is the umbilical cord that carries the electrical energy to increase the mass of its embryonic galaxy over time. Should we be surprised that Arp's view of the cosmos has almost biological overtones? In the final paragraphs of Quasars, Redshifts and Controversies, we see the measure of a real scientist, as Arp writes of his thoughts on matter generation in active galactic nuclei and quantized redshift. It is still just a working hypothesis, to be discarded or modified as further observations are made to test it. In fact, its major usefulness is probably only to promote further observations. Yet always the hope is that we have achieved some fuller, deeper understanding of the universe we live in." End of quote. The electric universe acknowledges the brilliance and courage of Halton Arp. Like Galileo, his contribution to science will be acknowledged for all time.
Yep. I think they will recognize Arp's work in the future, and he will get the recognition that he needed or that he deserved, because what he did and what has been confirmed by other cosmologists changes the view. It should change the view of every cosmologist out there to a different understanding of how this universe works and how it runs. I mean, in conjecturing that new highly energetic electrons will get bigger and more dense and start creating elements, and they become more luminous as these quasars grow into galaxies. Like Arp says, it has biological overtones. I'm dumbfounded at why cosmologists can't see this. Anyways, we'll move on to the Universe Cosmology Quest. Movie came out in 2004. And we'll watch a little bit of this, and then after that, I'll take all your questions and comments, because it'll be ended.
Come apart, they always say there's enough dark matter in the system to hold it together. But I've come to the conclusion that what it is that will unseat an established prejudice, a strongly established prejudice, is one observation.
One observation.
One single observation, usually a very simple one. The conclusion was very, very strong just from looking at this picture, that these objects had been ejected from the central galaxy, and that they were initially at high redshift, and the redshift decayed as time went on. And therefore, we were looking at a physics that was operating in the universe in which matter was born with low mass and with very high redshift. And as it matured and evolved into our present form, that we were seeing the birth and evolution of galaxies in the universe.
Greater and greater mass as it gets older.
If protoquasars ejected from the nucleus of active galaxies themselves evolve into new, younger galaxies, astrophysicists must find experimentally and observationally the mechanisms which describe this phenomenon. One model explains that the protoquasars are ejected, trapped in the galaxy's extreme magnetic field, aligned along the spiral arms, thus explaining the torn, disturbed features often observed in the galactic medium, and the frequent appearance of high redshift.
I'd like to pause for a second and mention that these quasars aren't only ejected through their axis, they're also ejected through their spiral arms, as Markarian 205 clearly shows.
Companion galaxies attached by filaments to a lower redshift parent galaxy. The other and most frequently observed alignment is when quasars appear to have been directly ejected out of the galaxy's active nucleus along its line of least resistance, creating a field of systematically high to low redshift quasars, or younger to older evolved protogalaxies. This is exemplified in innumerable systems like the one around the galaxy quasar field of NGC 3516. If one disregards the proposed redshift distance to these objects, observation clearly points to ejection as a likely explanation for their close vicinity to the central galaxies around which they are found. These results, though preliminary, are promising developments which may lead the way to new and exciting insights in cosmology.
One of the best and earliest of the really controversial things was a Seifert galaxy known as NGC 4319, which Chip Arp discovered that it has a protrusion coming out in the south direction from it, one of its spiral arms, and ending up on another galaxy known as Markarian. And people have tried to explain it away in all kinds of ways and tried to take false pictures to show that it's
False
not there.
pictures.
But I've seen the good pictures, which were the first really good pictures were taken by Jack Salenti.
NGC 4319 was part of some work that I did in the early 80s when I was a young astronomer, yet a faculty member, and people were coming up to me and saying, oh, I've written a paper to show that what Chip Arp has done is wrong. There were at least 3 famous papers right around 79, 80, 81. And it took about 5 minutes to look at these papers to see that they were flawed. And one of them was a paper that claimed to show no connection between NGC 4319 and the quasar, Markarian 205. So at that time, I had the opportunity to work at JPL using the new image processing facilities that had been developed for the Voyager program, in fact. And it took 1 hour's effort to show that there was some kind of a luminous feature between those 2 objects. I don't know what it is, but there's no question that there is a luminous feature, and it cannot be dismissed in the ways that it was dismissed in the early 80s.
Suddenly there appeared press releases from Space Telescope Science Institute, which was the research arm of NASA's Hubble Space Telescope. And this press release said that they were not connected, and it gave a Hubble Space Telescope picture. It was not very deep, and you could just see 2 objects and no connection between them. And in this press release, then they said that that this proved that there was no contradiction with the current expanding universe paradigm.
No connection between the 2 objects. So I looked at their picture, then I downloaded it, and it took me 5 minutes to show that it's still there. Now, I don't know what it is, but I think you face up to the existence of a feature and then you consider conventional and unconventional explanations. But I was really surprised that they felt it necessary to issue a press release saying it's not there, it's not real. It's the same thing we saw 20 years ago.
But it's hard to get people to look at this because they don't understand it. You see, it's again the non-cosmological redshifts.
That that the people who had been processing the pictures and released it must have known that the picture was there, and yet they chose to try to convince the public that that in fact it wasn't there and that everything was right with the current expanding universe paradigm.
It's a strange attitude. I don't understand it as a scientist, really. I think if that news release could have generated much more interest in astronomy than many of the more conventional news releases, because people would be talking amongst themselves, gee, what could that be? And then various people could offer scientific explanations. But to just sort of close the door, in a way, you could argue that Chip, or someone like Chip, who believes in an alternate interpretation, I'm sitting in the middle of the bridge, so it could be either way. He should feel strong because I interpret that as a manifestation of fear and uncertainty. Because if I really had confidence in my paradigm, I'd put it right out there and say, well, yes, there is a bridge there, but it's either this explanation or it's that explanation, but certainly it's not what Chip Arp says.
They have no explanation for it. That's why they would lie, would go to the resort to lying to the public about the bridge being there or not being there. Like he said, 5 minutes he looked at that image that NASA put out and he saw the bridge. 5 minutes. If you know what you're looking for, you can find it.
But instead just say it isn't there. That's a manifestation of fear, I think.
This misrepresentation of the results on a public level, published through a press release from a government supported institution, which was not refereed and which gave the wrong information, seemed to escalate, in my opinion and my colleagues' opinion, escalate the controversy into a publicity campaign, which was sort of like doing scientific research by press releases in an attempt to defend, as a sort of a last resort, a dying paradigm in physics.
I don't know what more one can do than the data are there, they've been got. We have to make sense of it.
I think in one sense they think it's bad to, quote, confuse, unquote, the public. Because if you believe in the standard paradigm with all your heart, you know it can't be real. I know it can't be real. You know, if I try to be at all rational within the context of the current Big Bang ideology.
The problem is to get them together. The problem is to get them together. We need some glue.
To anybody with an open mind, that should really prove the case that that quasars are associated with galaxies at most ordinary kind of redshifts, while the quasars have higher redshifts. Therefore, they must part of the redshift must be non-cosmological, not to do with the expansion of the universe.
Because I'm always thinking, if we can only be more rigorous, they will believe us. But I was wrong. I was very naive. It's got nothing to do with that.
The rolling of the Big Bang, it's largely been determined by the way people seized upon these ideas. And there's been tremendous amount of propaganda making claims that here we see everything happening and this has to be right.
The people that are in that field treat it like a religion.
I'm not so very objective. The reaction of the Orthodox astronomers to this idea is that it violates the Big Bang assumption, the Big Bang hypothesis, and therefore it cannot be true.
The amateurs tend to be more broad-minded than the people who have to earn their keep by being narrow-minded. I got it.
Was this worked out by somebody, or was it, did it just happen by chance? Which is really the same thing as saying, did the universe happen by chance? And I have to say, when I look at it, it doesn't look to me like all like chance.
Sir Fred Hoyle thinks there was a mind behind the creation of the universe. That it's basically biological.
Hey, are you done with this
Yes.
film?
Yes, I am done my presentation.
All right. Let's see, we got a warning here. Let's go back. Who are these people? I recognize Jeffrey Burbidge, Fred Hoyle. I think that was Margaret Burbidge, and I'm not sure who. And of course, Jack Salentic had a name associated with it. And I'm not sure who the last guy was that, let's go back to the,
that guy there?
That's Fred Hoyle.
That's Fred Hoyle, yeah.
Okay, and he was the second person that you showed talking. Now, who is this guy here?
Let me see here.
I believe that
I think he builds telescopes. I think he builds telescopes. Give me 1 second.
I didn't recognize the guy with the check shirt.
No, he's basically just a scientist that builds telescopes for these
Okay.
projects.
All right.
Trying to find them. Oh, wait a
Now,
second.
one of
Yes,
the
here he
things
is.
I want to point out is,
Hang
yeah,
on.
that
The
guy,
same as
John.
with the
Oh, that
Bible
was
Belt.
Dobson. Okay.
John
All right.
Dobson, telescope designer.
I know who John Dobson is. Okay. All right. Thank you.
You're welcome.
Now, I did want to comment on this. I'm not familiar with this film that you just showed.
Right.
It's new to me. I hadn't seen it before. Wasn't even aware of it. So
It's a
that's
two-parter. It's a two-parter, and it can be found on YouTube. Just type in Universe Cosmology Quest.
okay.
And my friend Greg J has part 1 and part 2 on his channel.
Okay, that's good. I'll take a look at the whole films.
Right. I
So you
recommend it.
presented. So yeah, I think I didn't know about this film, so that's good to know that. Thank you for that.
You're welcome. It opened my eyes. The first time I saw it, I was like, why are these people lying? My mom, when she encountered somebody that was lying to her, you could see the anger in her face. And I feel the same way. Whenever I encounter lies, I just get livid. It drives me bananas that these people could do this.
Well, they're not lying from their point of view. From their point of view, they're defending the
No, they're
truth as they
lying. They
understand.
obviously saw the bridge. They know it's there, yet they put out press releases saying that it's not there. Here's an image of Markarian 205 and its mother galaxy,
Well,
and there's no bridge there.
Yeah,
they
but from their
lied.
point of view, it's just an accident.
Well, there's more than just the one example.
Well, Rick, what I think your material that you're showing exposes something really beautiful. You have two parties, right? One conventional and one saying Big Bang is not correct. The party that's saying the Big Bang is correct has a different starting point. They have the starting point of the rhetoric, meaning this is the outcome that we accept. It is very similar to the outcome of God created the earth 6,000 years ago. If I come to you, and this debate is there too, by the way, and I have geological, between brackets, evidence that points back to 10,000 years history, according to the people that accepted the creation explanation of 6,000 years or whatever, they will say, your data is wrong. I know your data is wrong because I know the truth, being, Earth was created 6,000 years ago, and therefore your data must be wrong. This is a very similar case. It is simply a matter of what you accept to be true. That means the first party accepts the truth up front. We know the answer. It's a Big Bang. And the other party goes like, well, hang on. There could be another answer here. And it's a very fundamental difference, and therefore they will not accept that evidence. It's not so much lying. That's why I responded there. It's not lying. It's that just they are convinced your explanation cannot be true.
Yes, and I want to point out, I agree with you. I want to point out that the people in the film, Fred Hoyle was definitely an opponent of the Big Bang. And Jeffrey Burbidge, also has been skeptical, and his wife
Margaret,
Margaret,
his wife, yeah.
Yeah, also. And these are important people. I mean, these aren't just trivial people. These are important people. His wife
Well
Margaret
respected.
his wife Margaret was appointed to be royal astronomer, not royal astronomer, but she was in charge of the Royal Observatory in England. Okay,
Right.
so she wasn't a trivial person.
She's a bigwig. Well respected in her
Correct.
field. Many of these people that are talking
all of
about,
them were. Yeah.
yeah, all of them, all of these people that we're talking about, uh, Arp's work were well respected, and a few of them accepted his work as reality, as unequivocal. Like it said in the video, his work has been looked at by other people and confirmed just through that one galaxy, um, with smaller galaxies off to its uh, axis.
Okay.
I don't see how they can how they can rail against it. The only way they can do it is the same lies that many of the I'm gonna get a little political here for a second. Many of the left go into lies like crazy. They'll lie about everything just so that their point of view gets adopted. Lies are
Um,
lies.
okay. I do want to point out here, you mentioned Victor Ambart-Sumian. Now, I did a talk about Victor Ambart-Sumian, I think, back in the beginning of this group. I talked about him, mentioned him. He's pretty important, and he sort of predates what ARP did. And
He was the first one that postulated that active centers is where creation was taking place, where photons are slamming into each other, creating electrons, like has been found in the laboratory in the United States, in one of the schools in the States. They slam two photons together and poof, you get an electron.
I still
Energy
need to see some
creation.
evidence there, Rick, please.
Um, I invite you to Google it. It was postulated in the early 1930s
Mm-hmm.
by two physicists, and the technology to be able to run the experiment hadn't been invented until just recently. And they ran the experiment and they slammed two high energy photons together, and what was left, what they observed, was an electron.
okay, we got a minute.
I don't dispute their facts. I don't dispute their findings. I think that
I might.
yeah, but
Well, we got disagreement. No surprise there.
no, Google it.
All right. Um, Now, you didn't mention Vorontsov Phenomenov, which is a Russian astronomer who also suggested that galaxies are created by natural like processes and seeds and that sort of thing. That let galaxies grow by seeds. Right.
Right.
That's all. So this is not an idea exclusively Arp's
No,
idea. There
no.
are other people have suggested these similar ideas.
Yeah, but before our finding physical proof, they were just theories. Now,
Well, ideas.
yeah,
Yeah.
well,
Okay. I see
theories
what
are
you're
still
saying.
ideas. Until Art found these physical connections and pointed them out, proving that these thoughts are true now. They can't be anything else but true. That
All right.
objects are being to save their model, to save their paradigm. They will lie, they will cheat, they will do whatever it takes to save their paradigm. And they'll keep throwing ad hocs into the mix as well. I mean, this is it's not funny when you sit down and think about it. We're out here trying to find the truth, and then they're
They're
presenting
they're
us with
they're in the
lies.
business of they're in the business of making money,
Yeah,
and I think that's where the difference. Big science is about money. It's about
yeah, but you could change your paradigm and still make money and accept the new paradigm. and still get
Well, they're not very imaginative, and they're very protective of their fiefdoms. I saw this video yesterday about their building. European Southern Observatory is building this gigantic telescope, and the thing is huge. And I watched the video and I thought it was very interesting. But what struck me about it was the huge amount of money that is being spent building this
1.6
telescope.
billion dollars on that 36-meter telescope.
Right. That's just an astounding amount of money. And it's not in Europe, it's in Chile. So
Chile, yeah.
imagine all these countries in Europe are giving money to Chile so they can have a telescope in Chile. It's just an astounding
Well,
amount
I
of
mean,
money.
Chile is known for its high altitude and its thin atmosphere above their telescopes there. So it doesn't make it doesn't it's not strange for them to build a telescope there where they get the best view.
That's not really the point that I was making. The point I was making is these countries are kind of running out of money, and yet they're spending a lot of money on this telescope
Gotcha.
in Chile. And these are countries that are in economic distress now: Germany, UK, France. These countries are not really doing that well economically. Ireland is
Right,
another one.
right. Well, don't forget, it's not only governments who fund scientific research.
Well,
It's
it's a
also
lot of money and a lot of prestige on the line.
yeah, it's also the ultra rich that can throw money at this stuff too. So
right, but they have to justify spending this money. I mean,
right,
it's a huge amount of money, and they have to justify spending it. It has to give that, they have to find something, they have to discover something, they have to produce press releases, okay, to, show
to
that
justify
they're
the cost. Yeah,
correct. And there's a lot of careers on the line, a lot of money involved. So it's big science. It's big, it's industrial science. Um, and I think the idea of learning how the world really works is kind of gets lost in the mix. Um, that's no longer an objective.
yeah. I've downloaded 3 or 4 of his papers here that you guys can just go to haltonarp.com and download them yourself. They're all PDF, mostly PDF form. This one here is on a different site, but they're out there. You can find them, you can read them, and you can start to understand how the universe is an electric discharge, and plasma cosmology is more bio-like than people would like to admit. I think biology plays a huge role even in the cosmos.
Well, basically, I think this is an important point, and that is, it's not. It sounds like that people are saying that the universe is alive. Okay, and I I think basically is forbidden. I think that's the forbidden thing to say if the universe is alive. So that's kind of impermissible, is my view. But
Right. I see it
maybe
as
it would,
alive and connected.
right. But these are things that the mainstream says are not scientific concepts. But the analogy that the universe as a whole operates in a way that's analogous to biology might not be as upsetting to the establishment. But it does look like the universe behaves more in a biological manner or analogously to biology to a certain extent than the materialistic, mechanistic way. So they would like to have the universe work physically in terms of physical laws the law of gravitation,
Like a
these are the
machine.
laws. Right. It's like and that gives the physicists the priority, and they're at the top of the science heap, and
Or
they're applying their way of thinking about things to the universe.
or
And
everything is an island in space.
right, but unfortunately, their theory has a problem in that it doesn't really explain galaxy clusters very well, and doesn't explain clusters of
Nope.
clusters. And this theory, the idea of birthing, galaxies birthing, and putting out seeds, if you will, that then grow into mature galaxies, is basically explains clusters of galaxies much better than the mechanistic gas clouds collapsing idea. And also,
Yep.
you have large numbers of binary galaxies and binary stars as well. And their theory doesn't work very well at explaining how binary galaxies
Could exist. Yeah.
come into being. And they can't really explain how binary stars come into being very well. And then when it turns out that you have binaries of binaries of binaries, it's like where you have these systems where you have a binary system of stars, and then the stars that are parts of the binary system are binary stars, and then it turns out that the binary stars are binary too, and so it's
Yep.
like it goes binary, binary, binary goes down in a chain. They can't explain any of that.
Electric stress can explain the fission of a body out in outer space. Put enough electric stress on it, it will split to be able to accept the amount of charge that you're running through it. It will split and it will share that charge, just like a comet does. It grows a coma many times its size, its nucleus's size, many, many, many times its size. Where does that come from? That's an electric discharge phenomena. And the tails of comets are well known to be spiraling filaments. They're filamentary in their nature. They've been imaged many, many times, and they look like they're spiraling in behind the comet. Those are small
Let me
Birkeland
ask you the
currents.
question. I'm very sorry.
Go ahead,
How
bud.
how do you explain binary stars and binary galaxies? One of them you can see with your plasma universe, and the other one you cannot see at all. How you explain phenomenon?
Well,
Very
a
well
gal
known.
a galaxy will birth another galaxy, and then it will
I'm very sorry.
move.
I'm not talking about galaxies beyond or something. There are binary galaxies. One of them you can see, another one no. And stop at this point. Stop talking about something else. Answer the question. How you explain the existence of such binary galaxies and stars in your theory? Simple like this.
The ejection along the
Ejection
axis
of
of
what?
galaxy. Hey, let me finish, please. The ejection of quasars along the axis of galaxies, later growing into regular galaxies, will explain dual galaxies or pairs of galaxies. A large sun under electric stress will fission into two parts, maybe more, maybe ejecting some planets out of it at the same time. And that's the reason, and that's how we get binary systems, is from electric stress on bodies in space.
I would like to add the Birkeland currents and Z-pins effect there, Rick. They tend to, if I'm not mistaken, they tend to twist around each other like two Birkeland currents.
Yep.
So if you put the Z-pins there, you get like two nodes. That would be your double stars system, if you will. In response to Vladimir.
You could see two galaxies on each arm of the Birkeland current, or each spiral of the Birkeland current, but I think the model shows that the galaxy is pinched into existence between the two Birkeland currents, where the space is in between the twisting pairs of filaments, Ito. Not within the Birkeland current itself.
I don't know which way. I thought the other way. So each Birkeland current would have its own node, if you will.
No,
I do not know the theory well enough, but I was just brought it to the table that the Z-pinch effect could produce such a thing like a double star or whatever.
Wall talks about suns being shot out like buckshot along the axes of the galaxies and other suns, and like jets of suns. That's basically fission, like splitting apart of a larger body, and or jets of material being shot out, creating coalescing into objects that later become moons and planets and things like that.
Should we not have more observations then, if that's true?
Well, cosmology is a young science. It's only 100 years old.
Lots of stars and planets and galaxies.
Modern cosmology, I mean.
Yeah.
Has the research been carried on since our past?
I don't know if anybody is willing and brave enough to carry his work on. I mean, there were people in his time that confirmed his work, that showed that what he was saying was truthful, that it was reality, but I don't know if anybody's doing it today.
Markarian 205 examples, particularly.
I don't think so. I don't think anybody's brave enough. They saw what happened to Arp, and
I think they've decided that the Markarian 205 is an accidental alignment. And I think that if you were to bring that up to somebody, he'd insist that that's already been disproved, and
they'd show you the fake pictures.
Right. That was the effect of the press release. So I think that's a dead letter as far as the mainstream is concerned.
It's a dead cow.
The best way to bring it back is to find other examples.
Well,
he found multiple examples, Jim.
I meant more modern.
Oh,
this
okay,
was like 10 years ago, right? When Arp died.
Oh, this is more than 10 years ago. He found all this stuff in the 70s and 80s.
Well, I meant since he died.
Oh, since he died. Okay. No, again, I don't think anybody's carrying on his work.
Yeah, too bad.
There may be amateur astronomers that are carrying on his work, but they don't have access to the telescopes. They can only go over his data and run the numbers and verify his data that way. But
most amateur astronomers are mainly interested in pretty pictures, unfortunately.
Yeah, true.
What about the JWST? Has anybody asked? Has it ever tried to look at this object?
Hubble did, and they gave us
more resolution with.
And they gave us
JWST.
Potentially. Behind my shoulder is.
Right. Let's. I don't think the Markarian 205 is that big a deal. I think the one that's the really big deal is the first picture that you showed. You want to go back and show the first picture? The one with the quasar that's right on the end of a spiral arm.
Just a second.
That's to me, what's amazing is that they've decided to talk about the Markarian 205 when the other issue is
NGC 7603. This one here.
Put that picture up.
It's up.
I don't see it. You need to do the request.
Oh, the share? Oh, okay, hang on.
Actually, to me, the more important thing would be to disprove expansion.
Well, Arp's work with
there it is.
quasars
Okay, so
kind of disproves it.
Well,
so
I
you
meant
got
more
this.
recent.
You got this quasar sitting right there at the end of what appears to be a spiral arm. That to me is more, and this isn't unusual. There are a lot of galaxies that have binary galaxies that look like this, where there's a companion galaxy, they call it, that's sitting on the end of a spiral arm. And probably the most prominent is M51, the Whirlpool galaxy.
Okay. Well, like,
are you familiar with M51?
No.
Okay, but it shows a galaxy, a companion galaxy sitting at the end of a spiral arm. So that's an example of you might say a galaxy where the quasar has evolved into a companion galaxy. Anyway, you can look up M51, get a picture of it, and bring that up here. Okay.
I get a phone. Oh my God.
When we talk about things like a galaxy at the end of
there, you got it down at the bottom down at the bottom there. No, go right, go right, go right. You're going the wrong direction.
This one here?
No, go to the middle. There you go. There it is. M51. You see the companion galaxy is at the end of the spiral arm.
Yep.
Of the that's and this is kind of the most. This is probably one of the more spectacular or well known. There's lots of them that are like this.
Yeah, Arp probably has this in his Atlas of Peculiar Galaxies.
He has a lot of them.
How do we know that smaller galaxy at the top is at the end of a spiral arm? It appears to be, but it could be behind it, and that.
Well, that's the mainstream argument.
That's the mainstream argument. Yeah, that it's maybe 100 or 200 or 300 light years away, depending on its redshift.
I'm not making an argument one way or the other. I'm just asking a question, a methodological question.
Right. Well, that's the argument that mainstream says when they see a quasar at like Markarian 205 sitting on the edge of a galaxy. They say it's billions of light years behind it, not right beside it or part of it.
But I'm not sure if they do that in regard to M51.
I don't really know. Too much whether this has been thoroughly studied. The reason I brought this up is because this is a more it's kind of easy to see that it's a companion galaxy stuck on the end of a spiral arm of another galaxy. And these are not uncommon. That's the point. These configurations are not uncommon. Mainstream would say this is a collision of galaxies.
Yeah.
That's their explanation.
Where was I before there? Oh, Jesus. Okay. Yeah. Okay. Yeah. Well, on NGC 4319, what are these two blobs here? Right? They're quasars as well, you would think. They're probably different, have a different redshift than the center galaxy. I don't know that for sure, but I would think that they're partly being ejected as well. They look like they're being ejected, and they're connected.
This kind of allows you to understand why clusters of galaxies exist. Okay. And I think that's a key point.
Yeah.
That why do you have galaxies clustered around? Particularly, you have galaxy clusters that are dominated by a central galaxy that is usually they're E0s or ECD type galaxies, which are these also associated with radio sources, which means they're highly energetic and powerful. And so ARP would say they're spitting out seeds, and the seeds are quasars, and the quasars then evolve into companion galaxies that would then orbit around and form a star cluster. A galaxy cluster.
I think seeds was that other astronomer's description of them. He would have said quasars. I'm sure of that.
Well, the mainstream actually has this idea that quasars are seed galaxies, but their view is that that's only within the Big Bang context.
Yeah, so that they're very far away. They're moving away from us very quickly, and they're primordial. That we're looking at something that happened 10 billion years ago, something like that. But Halton Arp is showing us these quasars are not 10 billion years old. They may be far, far younger than that.
Well, they want the quasars to be formed at the very early phase of the universe, and
early galaxies are quasars. That's what they're called.
But then they have a problem. Then the problem becomes the idea that the gas that's created in the Big Bang then has to collapse to form these black hole quasars. I think they view quasars as being like black holes. And so the gas has to then form these black holes, which are quasars, and then they evolve into galaxies. It doesn't really seem to make a lot of sense to me.
No, black holes ejecting black holes.
Well, I think the idea is that, I don't really understand it, so I guess I shouldn't characterize it so negatively. But I think their idea is that quasars are formed at the very early phase of the universe. But how that happens, given that the Big Bang is supposed to create hydrogen gas, and that then collapses to form galaxies, seems kind of confusing. I'm not sure how that forms galaxy clusters and clusters of galaxy clusters. So they don't really have a theory that explains the hierarchy of objects being formed.
Well, the electric discharge that's going on in Sapphire created 9 of the 11 most common elements that we see in the cosmos within the chamber. They weren't present in the chamber before the experiment started, and they detected 9 of the most common elements in the cosmos in the chamber. I don't know what gas they used to initialize. Probably a hydrogen, but they detected 9 elements. That's your answer right there. That's where elemental creation happens, is in stars, and they disseminate their elements through their solar wind, and when they go boom.
Okay, that's the electric universe
due to electric discharge. Yeah. That's my viewpoint anyway. I mean, I see creation happening in the centers of galaxies and centers of quasars. There's creation happening there. That's
the Armbart-Simeon idea.
I guess I'd never heard of them before that, but it's the electric universe way of thinking. That's how
Well, they've
we see
adopted
the
the
universe.
Armbart-Somian hypothesis.
I think so.
And the Armbart-Somian hypothesis is that the stars emerge from these the centers of galaxies, which are viewed as compact objects.
Seyfert
And
galaxies, highly active centers of galaxies. Not all galaxies are active in the Seyfert mode. Our Milky Way isn't, but there are galaxies out there that are just highly active in spitting out objects along their axes and along their spiral arms.
right, that's basically the Armbart-Somian hypothesis.
Yep, that's how I
Hey,
see
And
the
Rick,
it's been
universe working.
adopted by other people. Huh? Excuse me.
say, Rick, in what you're showing now, we have displayed a catalog of discordant redshift associations.
That's one of Harp's books, yeah.
Okay. Are we to assume that the different redshifts observed in these objects, which are supposedly about the same distance from us, are due to different physical processes? And so the question I have is, what might those processes be to account for the different redshifts?
Age. The age of an object. If it's newly born, it will have a high redshift, 0.391. The older it gets, as you can see here, in object 2, its redshift is lowered from 3.39 to 0.30. This is the zone in between these two objects, sorry. Its redshift is lower. Now this object 2, beside this quasar here, object 1, its redshift is 0.2, which is lower than 0.391. Then you go to this object 1, its redshift is 0.057.
Okay,
hang on, James. Approaching the redshift of NGC 7603. It's newly born, its redshift is higher, and as it ages, its redshift will lower and lower and lower until it gets more closer to the parent galaxy. And this parent galaxy will probably, as it ages, its redshift will become lower and lower as well, until it turns blue shifted.
Okay. I'm accepting the redshift data as presented. I'm not questioning that.
Okay.
What I'm wondering is if the different redshifts, you talk about the age, but that doesn't really address my question, I think. I'm asking, do the different redshifts which you have displayed here indicate different physical processes causing the radiation which we observe here with our telescopes?
No, it's just the age of an object that's been ejected from an active galaxy.
Well, that's what I'm asking. What does just the age mean?
It's just the age. It's just, again, I go to, if it's newly born, it's got a high redshift. The older it gets, the redshift drops and drops and drops in a quantized manner.
Wouldn't that indicate that with age, as you say, that different physical processes are producing that radiation?
No, the same process is happening all the time. It's these quasars are getting bigger, they're growing as time goes on, and changing their redshift and becoming galaxies themselves.
Yeah, but Rick, what we're seeing is a shift in the spectrum, meaning, for example, the spectral lines of the hydrogen in your quasar, right? So one hydrogen atom, it emits a photon when an electron does the right thing.
Right.
That's what we see, and that is shifted. So I think, Jim, what you're alluding to is what are the underlying nuclear processes and why is it shifted?
It starts with lighter and lighter elements, and as it gets older, it building heavier and heavier elements.
Yeah, no. That may be true on itself, but that does not mean that you get a shift in the spectral line of your hydrogen. Your hydrogen, no elemental change here. No elemental change.
Не имеет, а имеет перемену. А он пытается одно связать с другим. И не получается.
Well, I think Ito understood my question, and it's not disputing what Rick is saying at all. I'm just probing into what the physical basis of these changes in redshift or discordant redshift associations, as Arp puts it, why they occur. What is the physical mechanism?
It was in the video.
Say, well, one is older, but that doesn't tell me what the physical mechanism is. Okay.
It was in the video. It was explained that the electrons are small and they get bigger. They grow in size to then change their shifting Doppler redshift.
Well, that seems to be a big speculation, actually. You might be right, but
Arp might be right. It's not me. I'm just parroting.
I think actually the question that Jim is posing here, underlying question that Jim is posing, is actually the answer that we're looking for. That might shed all the light on this whole topic about redshift / Big Bang. The cosmological debate that we're having.
Because if we can understand the quantization
exactly,
and then we will understand how things truly work.
And this is where the quantum mechanics realm comes in, right here.
Yeah. They're saying that the quantum realm isn't just in the microscopic. They're saying that it's in the macroscopic as well.
Okay, this is another issue that you didn't really go into in much detail, but this has to do with the studies that have shown quantization of redshifts in galaxies, and that the redshifts that are measured aren't a continuum. They show up in quantized jumps. And you didn't really talk about that or explain that. Jack Sulentic did a lot of work on that, and that's somewhat controversial, but that's the quantized redshifts issue.
Right, and it goes along with the intrinsic.
Perhaps maybe you might want to do a talk to explain that a little more clearly.
That's probably beyond my wheelhouse, Harry.
Okay. All right. We only have a few minutes left.
The details I don't do. I'll just do general.
All right. So what you presented us with is, I think a nice overview of Arp's work. I think we recognize that it's controversial. And disagreements about it. Doesn't really have a theoretical foundation. It's an observation. It's a set of observational results that he's speculated about what they mean. Okay, he doesn't have a physical explanation or a physical paradigm that explains everything down to the last nit like the physicists would like to have. They have a theory that starts with particle physics and explains the Big Bang, and then they explain everything along the way. Okay, the only problem is that the details don't really fit together into the picture that you get at the end of the process.
Right.
Okay.
Well, Jim, sorry to interrupt, Harry. Jim, this mapping here using CFID variables as lighthouses reveal galaxies much closer than their redshift. That's Hubble work, so that's newer work. You were asking for some newer data. Go ahead, Harry.
All right, we're coming up to the end here. Anyway, so I tried to summarize what the real point of the issue here is that the observations don't fit the theory. Okay, when you really look at the Big Bang and you take how they have tried to extrapolate from the Big Bang and their whole idea of creating the elements and how the elements form planets and galaxies and that sort of thing. It would have been fine if the galaxies were just evenly distributed across the universe and you didn't have any anomalous astronomical discoveries. Everything was just nice and neat. But what has happened is the observationalists keep finding all these strange things that don't really fit into the physical model that they postulated. And this is an example of observations that don't fit into their Big Bang model in a nice, neat way. And and what they've done in response is to say, well, we can push those aside and ignore those because they're just accidents and aren't really physically meaningful observations. And they like to do that quite a lot in astronomy and probably in science in general, although we don't know about it. This is a pretty obvious example of them ignoring evidence that doesn't really fit into their scheme.
Mm-hmm. I agree. It's a blatant misrepresentation of his work.
Okay, we got a minute left here. I do want to so thank you for your presentation. It was very interesting. I learned some things, and I know an awful lot about Arp, and I've read a number of his books. And so I learned some new things. Thank you for that.
You're welcome.
We do not have anybody scheduled to present next Sunday, so I want to urge you to people to participate and give us something to talk about, something to argue over, if you will, stimulate our imaginations. We do need somebody to present next week, next Sunday. I want to thank you for putting effort into it. And I'm wondering if we got less than a minute here, so we can't have any final comments other than thank you.
Yep. Thank you for listening, folks. Thanks for coming out and
Rick has shown some really good scholarship skills. Thank you, Rick.
Calling me a scholar. Wow. I don't think so, but thank you.
All right. Okay. Thank everybody for showing up and thank you for participating. So we need participation.